and welcome to the second video on exponents and roots. In this video, we will be discussing how exponential growth affects positive and negative bases, and we will also be discussing about exponent laws. So let us begin with today's lesson. Let us first discuss the exponential growth of positive bases. If a is greater than 1, then the value of a power n increases as the value of n increases. But if a is between 0 and 1, then the value of a decreases or approaches to 0 as the value of n increases. This is explained by a few examples. You can replace the base with numbers of your choice and see how exponential growth works. Now, the exponential growth works in a different way in case of negative base. For example, if we have a, that is the base, less than -1, then the magnitude of a raised to the power n increases as n increases, but sign changes between positive and negative. Kindly bear this in mind that the magnitude of a power n increases as n increases. If a is between -1 and 0, that is, if the base is between -1 and 0, then the magnitude of a raised to the power n decreases as n increases. Now, I would suggest to you to kindly take the help of number line to understand this concept well. Number line in GRE is like your best friend. Here are a few examples of exponential growth when the base is less than -1 and when it is between -1 and 0. Now, if you plot the answers on a number line, you will get very interesting results. Let us now have a look at the different laws of exponents. We have three main exponent laws, namely the product law, the quotient law, and the power of a power law. Now, the product law says that a power x into a power y is equal to a raised to the power x plus y. This can be explained by the example 2 raised to the power 5 into 2 raised to the power 3. We simply have to keep the same base and add the exponents, and we'll get the answer equal to 2 raised to the power 8. Now, the quotient law says that a power x over a power y is equal to a power x minus y. To understand this law, we can see the example of quotient law in this slide. Kindly note that if we want to apply the quotient law, the two bases must be the same. Now, the third law of exponents, that is the power of a power law, says that a power x whole raised to the power y is equal to a raised to the power x into y. And this can also be understood by the example 2 raised to the power 5 whole raised to the power 2, which is equal to 2 raised to the power 10. Right? We are now going to discuss the function of negative exponents. A raised to the power minus n is equal to 1 over a raised to the power n. This can be explained by the example 2 raised to the power 4 divided by 2 raised to the power 7. Now, the quotient law discussed earlier can make us understand this more effectively. The quotient law says that a power x divided by a power y is equal to a power x minus y. And if we simplify the expression with the same law, we get 1 over 2 raised to the power 3, which is equal to 2 raised to the power minus 3. A few examples here tell us how a positive and negative base works with a negative or positive exponent. Now, -7 whole raised to the power minus 2 is equal to 1 over -7 the whole square, which is equal to 1 over 49. Since the base has an even exponent, therefore the base will become positive when we simplify the expression. And minus 6 whole cubed is equal to 1 over minus 6 whole cubed, which is equal to 1 over 216, and the sign will be negative because the base has an odd exponent. Let us look at a couple of more examples of negative exponents. For example, if we have an expression 1 over 6 times 5, we can write it as 1 over 5 raised to the power 6, which is equal to 5 raised to the power minus 6. Similarly, if we have 1 over x into x, we can rewrite it as 1 over x squared, and it can also be rewritten as x raised to the power minus 2. 1 over y is equal to y raised to the power minus 1. Now what happens when we raise fractions to negative powers? In case of fractions, we have two scenarios. We can simplify it by using the formula a raised to the power minus n is equal to 1 over a raised to the power n, or we can also use the law, which is a over b whole raised to the power minus n is equal to b over a whole raised to the power n, right? Now if we use the first law, what we are going to get is 1 over 2 divided by 5 whole raised to the power 3, which is equal to 1 over 8 divided by 125, which is equal to 125 divided by 8. And if we use the second law, what we're going to get is 2 over 5 whole raised to the power minus 3 is equal to 5 over 2 whole raised to the power 3, which is equal to 125 by 8. The answer is the same, but the approach is different. Now let us see how we can apply the power of a product law and simplify an expression. The product law says that a raised to the power x into a raised to the power y is equal to a raised to the power x plus y. This means we must add the exponents if the bases are the same, right? Now if we have this expression a raised to the power 10 into b raised to the power 4 whole raised to the power 3, we can simplify it by writing the expression a raised to the power 10 into b raised to the power 4 3 times. And then we can separate a from b, and we can get the answer as a raised to the power 30 into b raised to the power 12. The power of a product law says that a power x into b power y whole raised to the power n is equal to a power xn into b power xn. For example, a raised to the power 3, b raised to the power 4, and c raised to the power 5, the whole raised to the power 4 is equal to a 12, b raised to the power 16, and c raised to the power 20. Now we can simplify the expression 5 into b raised to the powers 2 into c raised to the power 7, the whole raised to the power 3, by applying the same law. And we get the answer as 125b raised to the power 6 into c raised to the power 21. Now last but not the least, we are going to discuss the power of a quotient law. It basically deals with fractions. For example, if we have an expression a raised to the power 7 over b raised to the power 10, the whole raised to the power 3, what we are going to do to simplify it is we are going to write the expression a raised to the power 7 over b raised to the power 10 3 times. And what we're going to do is we're going to add the exponents, and we're going to get the answer as a raised to the power 21 divided by b raised to the power 30. So what happens is that the power of a quotient law says that a raised to the power x over b raised to the power y whole raised to the power n is equal to a raised to the power x into n over b raised to the power y into n. Now if we have a divided by b cubed the whole raised to the power 2, we can simplify it by multiplying the powers with the exponents, right? And we get a square over b6. Now with this, we come to the end of part 2 of our lesson on exponents and roots. Kindly note that I will be uploading part 3 of exponents and roots in the coming days. Since it is a very lengthy topic and a very important topic, I do not want you to miss out anything regarding laws or anything that is applicable in exponents and roots. So kindly keep watching this channel and prepare yourself the best way for GRE Quant. Thank you very much and best of luck to all of you. Goodbye.